So
If you,
there
Mhm.
wasn't a parameter for um, okay, you're plus or minus 90 or 45 to make that line 50% transparent. You imported a module for that, a library.
Oh yeah, so this is all in this is all so let me show you that. Yeah, so um there's some code that does the that implements the basic geometric transformations. So um reflecting a point across a line, um translating a point by a vector, glide reflection, which I don't think I actually have used much yet. I don't think I needed it, but I put it in there when I was doing this just so I'd have all the symmetries. Scale and shift, or rotation of a point around the center by an angle. Um, some conversion things. So I specified. So in that example, I had um, I had the angle specified by numbers, but I think I've also used in some patterns you can just specify M and V like mount for mountain and valley.
Can you do radians for that?
Um, you can if you want to. I mean, I haven't needed it. There's radians are used. I mean, some of that math, some of that stuff is used in the rotation in computing the rotations and things, but you don't. I don't really think in radians. So
What's the library? Like, where do you did you develop this or?
so these are direct implementations of all the math except for the Python built-in functions like pi, sine, cosine, and radians. Um, so that's all the math you need, basically, what you see here. Then I needed some helper functions to merge patterns. Like if you have two patterns and you want to join them, this basically does that. It merges the dictionaries, which is the data structure representation there, moving things by a unit uh, distance in a particular direction. When you're, I realize that when you specify some patterns, it's more useful to have a way of saying, "Oh, now move by 1 unit in the 30-degree direction," rather than calculating the coordinates by a priori. So there's some stuff to help you do that. So this is all the math you need. The stuff that we scroll through here, not that much. The Python code itself, there's a class to represent these patterns and to work uh, uh, with them to do the basic things like applying transformations to all the elements of a pattern. Like when you apply a symmetry, it can be a reflection, translation, glide reflection. It can be a scaling. That's not necessarily a symmetry, but scale and shift, rotation, merging, and then some other helpers, and then adding specifically adding a copy of the pattern after applying a symmetry to it.
That's super cool.
Then there's a function to make a grid, which I think was a you saw an action this was an early implementation of it, so I basically wrote it out by hand here. The repetition that creates a 2 by 2 uh, pattern, a 2 by 2 grid of these uh, patterns, the cells there. That I just wrote it out by hand, but later on I basically coded up slightly more generically so that you can just call a make a grid function when you have a pattern. Um, and so you don't have to figure out how far in X and Y a pattern extends. I was right about that. I'd forgotten that I wrote this. Um, and then there's additional stuff that I found useful when generating some patterns to repeat things and so on. Okay, so this is the one that actually draws the crease pattern in as an SVG file. And it first figures out the minimum maximum values and sets up a drawing. This uses a Python library called draw SVG. But again, all of the work is done here. It goes through list of edges and basically draws the lines using the indicated color. The color depends on the angle specified in the edge. So blue will correspond to the valley folds. The red will correspond to the mountain folds, and then numbers in between will you'll do a little calculation to figure out the opacity, like the absolute value of the fold angle divided by 180. And then you set the right sign for the number or the color comes from the sign. So basically, that's all. You've seen all of the code here. To actually run the examples I have, you basically just call up one of them. Let's